Hello, this is Ms. DB, and today we're going to go over a very important lesson from Chapter 4. This is Section 3 on congruent triangles. There's a warm-up today to do, so try to answer each of these questions and then we'll check your answers. Alright, if you are to name all sides and angles of triangle FGH, it would probably be quite helpful for you to have a sketch of this triangle. Where's my pen? Pen tool. Okay, so here I'm going to make triangle FY. Oh, I didn't plug it in. Sorry. So you hopefully made a triangle, any kind of triangle, and call it FGH. And you are to name all the sides and angles of FGH. So the sides are segment FG, segment GH, and segment FH. And the angles are angle F, angle G, and angle H. So it's got 3 angles and 3 sides. What is true about angle K and angle L? So in these 2 triangles below, angle J is congruent to angle M and angle I is congruent to angle N. So you should have remembered that those 2 other angles, K and L, would be congruent because of the third angles theorem. And then the last section says, what does it mean for 2 segments to be congruent? It means they have the same length. Alright, our objectives today are to use properties of congruent triangles and to prove that triangles are congruent by using the definition of congruence. Now, luckily, in the next section or 2, we will learn lots of other ways to prove that triangles are congruent that will not take as much time as this method. But this is what we'll start with. Our vocabulary is corresponding angles, corresponding sides, and congruent polygons. We've used the word corresponding before. When we talk about parallel lines cut by a transversal, we know that some of the angles will be corresponding. The corresponding angles are in the same position. In this case, angle 1 and 2 are both to the left of and above. So they're to the left of the transversal and above their parallel lines. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. So geometric figures are congruent if they are the same size and shape. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. Okay, this is important. 2 polygons are congruent polygons if and only if their corresponding sides are congruent. So they have to have congruent corresponding sides. Triangles that are the same size and shape are congruent. So congruent polygons have to have, I'm going to write this out a little better. And you know what, since we're talking about triangles, that's an N. I'm going to just do this with triangles instead of all polygons. They have corresponding angles and sides congruent. So all their angles are congruent, well, all their corresponding angles are congruent and all their corresponding sides are congruent. Alright, here's an example with a triangle. Here we have triangle ABC congruent to triangle DEF. Corresponding angles are marked with the same little number of circular little angle markings. So angle A is congruent to angle D. See, we got that one. Angle B is congruent to angle E. Angle C is congruent to angle F. Look at how they're labeled. We have triangle ABC congruent to triangle DEF. The A and the D are corresponding angles. If they put the A first and the D first, those 2 go together. The B and the E go together, and the C and the F go together because they're last. For the side lengths, it's easiest to look at a diagram to do side lengths, but A had 1 angle mark, B had 2. So the side between them is side AB. And the angles that correspond to A and B were E and D. So the side that goes with that is DE. Now be careful, I said ED, but DE is the way you'd have to write it because that D was the angle marked with only 1 mark, and then there's the E with 2 marks. You can also look at the way they wrote to find the segments. So here's AB, listed the first two letters, and here's DE, first two letters. Their corresponding segments. And then the next two segments they have on there is BC and EF. Here's BC, here's EF. Or you can say here's BC, here's EF. Two marks on each. And then looking at the label ABC and DEF, A and C, they're skipping over the B, and D and F, they're skipping over the E. So the way that you write your congruent shapes is very important. They also have an example with a polygon. In this case, it's a rectangle, and you can see that it's very similar, except there'll be more congruent angles and more congruent segments. Two vertices that are the endpoints of a side are called consecutive vertices. For example, P and Q are consecutive vertices. In this picture here, we have P and Q are consecutive vertices, Q and R are consecutive, R and S are consecutive, and S and P are consecutive. To name a polygon, you write the vertices in consecutive order. So you just go either clockwise or counterclockwise. You can't jump around. So we could name this quadrilateral, we can name it PQRS, or we could start at Q and go QRSP, or we could start at R and go RSPQ, or we could start at S and go SPQR. We could even go the other way. We could say QPSR, PSRQ. So there's many ways of naming one figure. However, you cannot jump, like go diagonally. We can't name this PRSQ or something like that. That wouldn't work. So when you name your triangle, it's very important, because we're working with mostly triangles in this chapter, we could name this triangle XYZ, or you can name it YZX or ZXY, or you could go the other way. But you have to just be careful that you're picking the same direction if you're going to name it to be congruent with another triangle. When I do mine, I usually go clockwise, and I don't know, I tend to start at one of the upper ones, but that's just one method. You don't have to do it that way. Okay, so like we already talked about, when you write triangle ABC congruent to triangle DEF, you are also stating which parts are congruent. If you're really good, you could look at this statement and you could name all the corresponding parts without drawing a picture. I don't really want you to do that. You have to, at least on your own scratch paper, draw a sketch. So I drew a triangle, and I'm going to name my triangle PQR, and my other triangle STW. Now I'm going to name all the parts that correspond. Vertex P corresponds to S. Vertex Q corresponds to vertex T. And R corresponds to W. And so we label them by putting 1 angle mark on P and S, 2 angle marks on Q and T, and 3 angle marks on R and W. Now let's name the segments. PQ would correspond to ST. Mark those both with 1 segment mark. Then we would go QR and TW. QR will get 2 marks, and TW will get 2 marks. And then finally, PR gets 3, and SW gets 3. And there we've got everything. Now the last part to do then is to write down which angles are congruent to each other, which now you can clearly tell from your picture, and which segments are congruent to each other. Remember, the symbol for congruent is an equal sign with a curve above it. If you're using typing, like in Word, and you can't find the symbol for it, you can write the word congruent. Do not use an equal sign to mean congruent. It's not the same thing. So we have angles. You can use the less than symbol to make an angle mark too. And then it's very hard to make a line above without having to like insert an equation. So we would just write segment. I would just write SEG. Segment PQ is congruent to segment ST, and segment QR is congruent to segment TW, and so on. Is how I'd write that. All right, here we have some polygons instead of just a triangle. A polygon is any figure that's made up of straight sides, closed figure. These happen to be rectangles. So it says to identify all pairs of corresponding congruent parts. So I already drew them out, and now I just have to label L, M, N, P. Now, L was first, and I'm going to put E here. I won't have to put E here. I could maybe put it at the bottom and say they've been like reflected or something, but this makes it the easiest. So that means that L corresponds to E, and M corresponds to F, and N, that's supposed to have 3, corresponds to G, and P would get 4, which is hard to draw, and H would get 4. So P is congruent to H. And then you do the segments. So there's all the angles, and then for segments, you'd say segment LM is congruent to EF, and segment MN is congruent to segment FG, and so on. All right, here we are going to now use what you've just learned to find missing parts. So it is given that triangle ABC is congruent to triangle DBC. Well, before I go any farther, label your triangle. So A is congruent to D, because you see they're both listed first. And B are the same. A, B, C. I guess these two are how they mean for it to be. And then C, well, if this one is 90 degrees, then this one's going to be 90 degrees because they form a straight line, which is 90 degrees. So that means that we know that angle ACB is going to be equal to 90. And that's going to be very helpful information for us. We're supposed to be finding the value of x. So because we have perpendicular lines, they're 90 degrees. So angle BCA is congruent to angle BCD, which means that then finally you can write your equation. Now, it doesn't say to write a two-column proof, so this part here is optional when you're solving a problem. This is the background of where we got to the 90 degrees, but you wouldn't have to write all those steps. You would just need to write this step, 2x minus 16 equals 90, and solve for x. You get 53. Okay, here's another one. In this one, it says again that triangle ABC is congruent to triangle DBC, and they want us to find the measure of angle DBC. So this time, I'm just going to mark the congruent parts again. We know this is 90, and we know these two are equal. So this time, we're given some different information. We know that all three angles are going to be equal to 180 degrees from the triangle sum theorem. We found in the last problem that whatever angle ACB is was 90. So now we're going to substitute in, and then we have that the measure of angle ABC plus 139.3 is equal to 180, and then we subtract and we get 40.7. Now that's this angle up here, but they're marked congruent. These two are congruent to each other because all the corresponding parts of congruent triangles are congruent. So therefore, triangle DBC is congruent to triangle, or angle DBC is congruent to ABC because corresponding angles of congruent triangles are congruent. Here's a shortcut for this reason. Corresponding is C, and then instead of angles, I'm going to change that to parts. Corresponding parts of congruent, here's the C, triangles, that's a T, are congruent. Corresponding parts of congruent triangles are congruent. CPCTC. If you want to show that if you show that you have two congruent triangles, or you're told that you do, then all of their corresponding parts will be congruent. So this right here is a reason you can use in your proofs of congruent triangles and showing that their parts are congruent. CPCTC. Okay, let's see about this one here. This one's using segments. So this time they're giving us triangle ABC is congruent to triangle DEF again. A is congruent to D. B is 53, will be congruent to E. So I already know this is 53 because they're congruent, right? And C is congruent to F. C is congruent. Angle C is congruent to angle F. Also, segment AB will be congruent to segment DE. AB will be congruent to segment DE. Well, already then I know that 2x minus 2 is equal to 6. And I know some other stuff. If I need to, I know that BC will be congruent to EF, and then that other third side will be congruent as well. So in order to proceed step by step, they're labeling their sides that are congruent. Definition of congruent parts mean that if you have congruent segments, then their lengths are equal. And then they substituted in and wrote their equation and solved for x. So x is 4. Now that you know that x is 4, let's see, this was the same as this was the same as this, and let's see, B was the same as E, this was 53, so C is the same as F. So if I want to find the measure of angle F, it might be easier to find the measure of angle, corresponding angles of, this is CPCTC right here. Angle ABC is congruent to angle DEF. Yep, already got that on there. So that's equal to 53. Okay, and then we now know that 53 plus 90 plus whatever this is going to equal 180 degrees. And then we just take 180 minus 143 to get our solution. And this was not meant to be a whole proof, so you don't have to show all of these steps. But you do need to at least, put down that you know that angle E is 53, and then that you took 180 minus 53 minus 90 or something like that to get the answer. Or you could add 53 plus 90 together first, like they did, and subtract. Okay, now here's a proof. See, it says proving. Angle YWX and angle YWZ are right angles. Okay, that's a given. YW, this segment here, bisects angle XYZ. Well, what does bisect mean? If you bisect an angle, you turn it into two congruent parts. This angle would be the same as this angle. W is the midpoint of XZ. Well, what's the definition of midpoint? Says that you will get two congruent segments here. XW would be congruent to WZ. And also we're given that XY is congruent to YZ. We're given so many congruent things here. We know this is 90 degrees. The only thing we're not given is that angle X is congruent to angle Z, but we could say that they are because of the third angles theorem. It's a right triangle. We know that this angle is congruent to this angle. This angle is congruent to this angle, so therefore the third angles will be congruent. And then how do we know that the third side is congruent? Because it's the same exact side. So YW will be congruent to YW. All right, here's the whole proof. I want that little picture here, but I don't have it. All right, let's write down our proof here, and then we'll just check our answers. So in order to prove that we have congruent triangles at this point in your life, you have to put down that 3 angles are congruent to each other and that 3 sides are congruent to each other. If you can do that, then you can say that the 2 triangles are congruent. So let's write our given down. And angle YWZ are right angles. Given. I gotta look it up what it's called. Right angle congruence theorem. Okay, I forgot the exact name. The right angle congruence theorem says that that means that they are equal to each other. They're congruent. All right angles are congruent to each other. So there I've got one angle congruent to one angle. Okay, 2 angles left and 3 sides left. Also, I know I'm given that YW bisects angle XYZ. That's given. What does that mean? We said what it means already. It means that by definition of angle bisector, that angle XYW is congruent to angle ZYW. That's the definition of angle bisector. Okay, got 2 angles congruent to each other. See? Angle, angle. Okay, other thing. Oh, here's another given. W is the midpoint of segment XZ, given. What does that mean? By the definition of midpoint, we know then that XW is congruent to WZ. So now we have a side. So we've got 2 angles and a side. Well, here's another side. XY is congruent to YZ. That was given. Given. Okay, we've used up all of our givens, and after 3 of the givens, we also wrote a statement that we were able to write from the given. Now let's look and see what else we know. We know, let me fill in what we do know too. We know this is congruent to this, and this is congruent to this. Okay, we also know, let's do another angle. We know that angle X will be congruent to angle Z. Do you remember why? Third angle theorem. So we've got 1, 2, 3 angles, very good. We have 1, 2 sides. We need one more side. The last side is this side that is shared. So finally, we are going to get to use the property of the reflexive property. So I ran out of room, but this would be a statement, and this would be the reason at the end. So the reflexive property says that a segment is congruent to itself. So therefore, now we have, that's a side, now we have 3 angles and 3 sides. So we prove that every single part of all the corresponding parts of our triangle are congruent. So our last statement then is to say that triangle XYW is congruent to triangle ZYW because of the definition of congruent triangles. There's our proof. I told you it was going to be long. It wasn't hard, but it was long. Okay, ready for this one? This one I copied and made smaller so we could see the picture and the reasons at the same time. All right, so here we've got AD, here's AD, is going to bisect BE. Well, if 2 segments bisect each other, it creates congruent, this would be congruent, and this would be congruent. Those 2 segments will be congruent. Oh, look at that one already had 1, so I'll put 3 on this and 3 on this. So our first given is going to let us write 2 different sets. Oh, they started with something else. Okay, angle A is congruent to angle D. Fine, they started with that. Great. Then they put that angle BCA is congruent to angle DCE. Let's see what they did here. They put that this angle is congruent to this angle because they're vertical angles. You can write for that definition of vertical angles, or you can just write vertical angles. They wrote vertical angles are congruent. You could write vertical angles theorem too. Okay, next step, angle ABC is congruent to angle DEC. ABC. Well, they've already got 2 sets of angles congruent, so that only leaves the third angles to be congruent. So the third angles theorem says that those angles must be congruent. All right, now we have segment AB congruent to segment DE. That was given. Now, it's interesting that they didn't start with their first given. They still haven't even used that one. Then they have the 2 lines, 2 segments bisecting each other, and then they're able to say what I had said at the beginning, that created 2 pairs of congruent segments. So we've got angle angle, angle, side, side, side. 3 angles congruent, 3 sides congruent. So finally, we're able to say that the two triangles are congruent because of the definition of congruent triangles. So there was nothing too complicated in this proof at all. It was mostly just saying, how do we know that the angles are congruent? How do we know the sides are congruent? And they gave us, there was a ton of givens in here. Look at all those things that were givens. Here's an application problem. This is a diagonal bars across a gate to give it support. Since the angle measures and the lengths of the corresponding sides are the same, the triangles are congruent. Okay, so we're given that PR and QT bisect each other. That means that we will have some resulting congruent segments. We also know that angle PQS, this angle, is congruent to RTS, this one, and that segment QP is congruent to segment RT. So we already are given, or in the given, all 3 sides being congruent. You can use vertical angles again. Always look for vertical angles. Vertical angles are congruent. And let's see what else. Oh, well then we have also 1 angle, 2 angles. We can use the third angles theorem then to say that the last ones are congruent. So you're going to be able to prove that these are congruent because all of the different parts are congruent. So they wrote down all the givens. The definition of bisector, remember that resulted in 2 pairs of segments that were congruent. Vertical angles theorem, they used that just like we said they would, and then the third angles theorem. So we've got side, 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 angle, 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 which is that the 2 triangles are congruent by the definition of congruent triangles. And as I said, we are going to learn shortcuts to proving that triangles are congruent so that we don't always have to say that all angles and all sides are congruent. And you'll be happy when we get to that point. All right, thank you very much. Let me know if you have any questions on your assignment.